Hello students, today we will discuss about one most important topic which we call as electric dipole moment. Electric dipole moment. This is a new term to you. So first of all you should understand the meaning of this word electric dipole. What this electric dipole is. You all have idea about the magnetic dipole. As magnet has two poles, north and south, so we call it as magnetic dipole. In the same manner, if two equal and opposite charges are placed at a very small distance, they form a electric dipole. Electric dipole means a system of two equal and opposite charges placed at a very small distance. Such as if you have two charges, one is here, other is here, both are equal in magnitude but opposite in sign, and they are placed at a distance 2a apart, which is considered to be quite a small distance. So this system we call as the electric dipole. Once you have the electric dipole, you must have the dipole strength, or we call that as electric dipole moment. What this term electric dipole moment is, just try to understand this. So electric dipole moment gives the strength of electric dipole. How powerful the electric dipole is. जैसे हम जानते हैं कि मैग्नेट है, छोटी मैग्नेट है, तो छोटी मैग्नेट की स्ट्रेंथ कम होती है, वो कम दूर तक अपना प्रभाव छोड़ पाती है. लेकिन अगर बड़ी मैग्नेट है, पावरफुल मैग्नेट है, इलेक्ट्रोमैग्नेट है, तो उसकी स्ट्रेंथ ज्यादा होती है, वो ज्यादा दूर तक अपना प्रभाव छोड़ पाती है. उसी तरीके से इलेक्ट्रिक डायपोल भी कम स्ट्रेंथ के या ज्यादा स्ट्रेंथ के हो सकते हैं. इस बात पर डिपेंड करेगा कि उनके ऊपर चार्जेस का कॉम्बिनेशन जो है वो कैसा है. क्या चार्जेस बहुत छोटे हैं या चार्जेस बहुत बड़े. अगर चार्जेस बड़े होंगे तो ऑब्वियसली जो उसकी स्ट्रेंथ है वो भी ज्यादा होगी, उसका प्रभाव भी दूर तक होगा. तो यहां पर इलेक्ट्रिक डायपोल मोमेंट, it gives the measure of the strength of the electric dipole and is given by P symbol and equals to Q into 2A. Here 2A is the distance between the two charges, or you may call this as the length of the electric dipole. My dear, you are placing here a vector sign. It is important to note that why we are placing here a vector sign, because electric dipole moment is a vector and 2A is simply the distance. But the dipole is quite small. That's why this distance is equal to the displacement. So we are placing here a vector sign. So you can represent electric dipole, or you can define electric dipole as a product of either of the charges and the distance between them. Either of the charges and the distance between them. So you have Q into 2A. If we think about the unit of this dipole, you have Coulomb meter from here. Unit of charge is Coulomb and unit of 2A distance is meter. So you have Coulomb meter as the SI unit for electric dipole. Based on this electric dipole, we have to discuss an important topic, which is electric field on the axial line of an electric dipole. Electric field on the axial line of an electric dipole. Just try to understand how we are able to find this electric field on the axial line. What the term axial line means? Axial line means at any point lying on the axis of that dipole, that we call as the axial line. So how we can find that? Just look at this. So if you consider an electric dipole AB having charge plus Q and minus Q, having length 2A, having center at O, and suppose here somewhere here there is a point P which is lying on the axial line, so which is at a distance R from the center O of the dipole. We have to find the electric field at this point P. We have to find the electric field at the point P. To find the electric field at the point P, what we have to note? We have to first find the electric field at the point P due to this charge, then the electric field at the same point due to this charge. So if you want to write here EA, which is the electric field at the point P due to the charge plus Q placed at A, is equals to how much? K Q over distance is AP. So AP is square. This is the formula of electric field. 1 upon 4 pi epsilon naught Q over R square. You are placing here. So this will further be equals to K Q over, in place of AP, what you can write? You can write here, this is A, this is R. So R plus A, this distance. So R plus A whole square. And the direction of this field EA is, along AP. Along AP. It is from A to P. Why? Because this is a positive charge. And due to the positive charge, the electric field goes outwards. So direction is along AP. Along AP. And say this is equation number 1. In the same manner, we can write here the value for EB also. Means the electric field at the point P due to the charge placed at B, which is the negative charge. Here negative and positive represents only the direction. So here now EB can written as K again Q over this distance BP square. BP or PB square, which will further be equals to K Q over, in place of PB what you can write? You can write in place of PB R minus A. So R minus A square. I think it is clear? Okay. Now what about the direction of this EB? EB is along PB. So you can write here along PB. And say this is equation number 2. But my dear, electric field is a vector quantity. So you need here the net field due to the system of charges, due to this whole dipole. Therefore, the net field at P is E axial equals EB minus EA. Why EB minus EA or EA minus EB? What you can write? EB minus EA. Why? EB is more stronger than EA. Why? Because this point is quite near to point P. So EB minus EA. When the charge is very near, means the field is quite stronger. This charge is quite at a far distance, so the field is little bit weak. So that's why this component is more and this is less. So you are here doing that EB minus EA. The direction is along PB. So you may write this as along PB. Now if you put the values of these quantities, what you have? So you have EB K Q over PB square minus EA K Q over PB square, or you may write directly here that R minus A square and here R plus A square. So further just take KQ common and you are left with 1 over R minus A square minus 1 over R plus A square. You have this thing. After this, when you further simplify, you can write this as KQ. Here the LCM is R square minus A square whole square. And here you have R plus A whole square minus R minus A whole square. You can open this bracket by any of the identity, either A plus B whole square or A minus B whole square or A square minus B square. You have the same result in both the cases. So what you can do here further, K, Q, and if you simply open this by A plus B whole square, you have R square plus A square plus 2AR. In the same manner here also you have R square plus A square minus 2AR over what is here? R square minus A square whole square. You have this thing. So you can write this as further, from here you can see that r square and this minus r square get cancelled, a square minus a square get cancelled, and you are left with 4ar. So you have E axial is equals to KQ. Within bracket you have 4ar over r square minus a square whole square, this thing. Or you can put the value of k 1 over 4 pi epsilon naught. Just take this inside and you have 2q into 2a into r. I think 2 into 2 4 a and r, q from here. You have to simply rearrange this in this form over r square minus a square whole square. This term we call as electric dipole moment P, which is equals to q into 2a. So you may write but q into 2a is equals to P. So you can place this in place of this as P. So further you have 1 over 4 pi epsilon naught 2 P r over r square minus a square whole square. This is E axial. This is the equation number 3. Now further, if we do some assumptions, if the point P is quite far from the dipole. So if point P is quite far from dipole, you have, that is, r is greater than a. So what you can do here? A square can be neglected. So a square can be neglected. Once you neglect this a square, you have E axial is equals to 1 over 4 pi epsilon naught 2 pi r over, if you neglect this or if you put this as 0, you have r की power 4. R से R की पावर 4 को काटिए, you will have 3. So what is left here? E axial is equals to 1 over 4 pi epsilon naught 2p over r cube. And the final expression you have after assumption. What assumption you have made? That if point P is quite far from the dipole, then in that case you have the electric field on the axial line as 1 upon 4 pi epsilon naught 2p over r cube.